Good day everyone! Welcome sa panibago nating tutorial series. So this is Information Assurance Security 2 series. This is part 2 and for today we are going to continue talking about network fundamentals. So we are going to discuss different types of networks. On our next topic, we will be covering different types of network. As we have that computer networks allows computer to connect and communicate with different computers. So we need to understand that how we are connected. So we have here different types of networks. First is PAN, stands for Personal Area Network. Then LAN, stands for Local Area Network. MAN, stands for Metropolitan Area Network. WAN, stands for Wide Area Network. SAN, stands for Storage Area Network. CAN, stands for Campus Area Network. WLAN, stands for Wireless Local Area Network. EPN stands for Enterprise Private Network. And for the last one, we have VPN stands for Virtual Private Network. So, Personal Area Network is basically a computer network that organizes individual for personal use only. This could be inside a small office or at your home. The network is typically managed for a single computer but it can be accessed from any device. This type of network provides great flexibility. It has capabilities like you can send a document to the printer in the office. While you are just sitting with your laptop, you can upload a photo from your cell phones to the desktop or computers. And you can also watch movies and online streaming services to your TV. So basically, this personal area network which provide data transmissions among devices such as computers, smartphones, tablets, and personal digital assistant. Next, we have the local area network. So local area network is basically a group of computers connected to each other in a small area such as a building, a computer laboratory, and a office. A LAN is private network owned and maintained by a single organization. LAN is basically used for connecting two or more personal computers through a communication medium, such as we can use twisted pair cables. LAN are typically used for single sites where people need to share source among them but not the rest of the outside world. Then we have Metropolitan Area Network. This is a combination of LANs, a computer network that interact users with the computer resources in a geographic region of the size of a metropolitan area. It consists of a computer network across the entire city. A metropolitan area network covers larger area or a region local area network because MAN is a combination of two or more LANs but depending on its configuration. This type of network can cover several areas. A MAN is operated a single entity such as government agencies or large corporations. Then next, we have Wide Area Network. Wide Area Network is a network that exists over a large-scale geographical area such as state or countries. A1 connects different smaller networks like it can be the combination of multiple LANs and multiple MANs. WANs uses technology like ATM that is asynchronous transfer mode. Frame relay basically a packet switch network that allows remote devices to communicate with each other. Alright, then next we have storage area network. So as you can see in the diagram, a specialized high-speed network that provides block-level network access to storage. SAN are typically composed of hosts, switches, storage elements, and storage devices that are interconnected using a variety of technologies, topologies, and protocols. Also, it can be accessed in the same fashion as a drive attached to a server. It is basically storing all your data. Then next, we have campus area network. From the word itself, it is for particular campus or corporate area network. It is basically for a smaller network. So a campus area network, basically a network of multiple interconnected LANs in a limited geographical area. Basically, a campus area network is larger than a local area network or LAN but smaller than a metropolitan area network or a wide area network. Next, we have wireless local area network. So basically, it is a LAN based on wireless Wi-Fi network technology. As I told you before, that wireless area network is a technology that is using a clear local area network having the upgrade version of wireless technology. A wireless LAN is a wireless computer network that links two or more devices using wireless communication within a limited area. Because LAN is for limited area, that is why the value LAN or wireless LAN is also for limited area but having the wireless technology. Next, we have enterprise private network. Basically, this type of network are built and owned businesses that want to securely connect. It serves the original purpose or private network where data is protected. A private network is enforced with many restrictions in order to create a secure environment. That's why mostly organizations use enterprise private network to maintain the integrity and the confidentiality of their data network. Then last, we have the virtual private network. Virtual private network extends a private network across to a public network. And also it enables users to send and receive data across shared public networks. VPN is encrypted connection that helps ensure the sensitive data is safely transmitted. And our next topic is network components. So basically, as a system admin, network security admin, or a network security specialist, you must understand networking components and you need to have a good understanding of these commonly used networking devices. Each of these devices that we are going to discuss fulfill a specific role. However, only the largest and most complex environments use all of them. So let's begin our first discussion with the hub. Hubs are networking devices operating at the physical layer of the OSI model that are used to connect multiple devices in a network. They are generally used to connect computers in a LAN. And there are three types of hubs, but initially hubs were passive devices. However, with development of advanced technology, active hubs and intelligent hubs came into use. Passive hubs connects nodes in a star configuration by collecting wiring from nodes. They broadcast signals onto the network without amplifying or generating them. As they cannot extend the distance between nodes, they limit the size of the LAN. Active hubs amplify and generate the incoming electrical signals before broadcasting them. They have their own power supply and serves both as a repeater as well as connecting center. Due to their generating capabilities, they can extend the maximum distance between nodes, thus increase the size of the LAN. Intelligent hubs are active hubs that provide additional network management facilities, and they can perform a variety of functions of more intelligent network devices like network management, switching, providing flexible data rates, and etc. Next, we have routers. Routers are networking devices operating at layer 3 or a network layer of the OSI model. They are responsible for receiving, analyzing, and forwarding data packets among the connected computer networks. When a data packet arrives, the router inspects the destination address, consults its routing tables to decide the optimal route, and then transfer the packet along this route. Alright, so next is switch. Switches are networking devices operating at layer 2 or a data link layer on the OSI model. They connect devices in a network and use packet switching to send, receive, or forward data packets or data frames over the network. And of course, we have NIC, stands for Network Interface Card. A network interface card is a hardware component without which a computer cannot be connected over a network. It is a circuit board installed in a computer that provides a dedicated network connection to the computer. It is also called Network Interface Controller, Network Adapter, or LAN Adapter. And it is also allows communications between computers connected via local area network, as well as communications over large-scale network through Internet Protocol. Okay, so next is modem. Modem stands for modulation demolition. A modem converts the digital data signals into analog data signals. They can be installed within the computer in a development slot applicable for it. There are frequently two types of modems. We have standard modem and window modem. The standard modems use generic devices drivers and they can be internal and external ones. The internal modems do not need much physical structure. They can be installed into a compatible development slot. The external modem is connected through one of the COM port to the computer through a cable called null modem cable. A window modem is a private plug-and-play tool. It requires a particular device driver supported by the Windows operating framework to function correctly. Next, we have cables. A wire that used to connect more than one computers or other devices such as printers and scanner to each other. Then we have the clients. The clients request a source and the server provides the resource. A server may serve multiple clients and at the same time while a client is in contact with only one server. Both the client and server usually communicate via a computer network but sometimes they must reside in the same system. Last one, we have the server. Servers are computers that runs operating system and hold the data that can be shared over a computer network. The next topic that we are going to discuss is the network protocols in TCP protocol stack. So as we discuss about TCP model and its layers, so accordingly with respective protocols related to those layers, like if we are talking to network layer in that particular layer, we use protocols like Ethernet, token ring, and frame relay. Okay? On the internet layer, we use IP, ICMP, IGMP, and IPSec. And for the application layer, we use protocols such as TCP and UDP. And at the application layer, we use protocols such as HTTP, HTTPS, FTP, TELNET, NTP, DHCP, IMAP, LDAP, HHS, TLS, SSL. These are the protocols that we are going to discuss so that you can understand how they work, what they work, and what it's implemented on this particular layer. So let's begin with HTTP, HTTPS that works on the application layer. HTTP or the Hypertext Transfer Protocol is an application-level protocol for distributed, collaborative hypermedia information systems. This is the foundation for data communication for the World Wide Web since 1990. HTTP is a generic and stateless protocol which can be used for other purposes as well, using extensions of its request methods, error codes, and headers. So next is FTP. FTP represents File Transfer Protocol and it is a standard internet protocol supported by TCP/IP used for transmitting the files from one host to another. FTP needs TCP as a transport protocol to help the reliable end-to-end connections and executes two types of communications in managing the data transfers. FTP opens a data connection when a user concerns a command requiring a data transfer, including a request to retrieve a file or to view a list of the files available. Therefore, an entire FTP session can open and close without the data connection ever having been opened. In other words, when a client starts an FTP session, the control connection is open, and the data connection can be opened and closed multiple times if ever files are transferred. The next, we have the TELNET. TELNET is a protocol which is part of the TCP/IP suite. TELNET allows you to control a remote computer from your own one, and it is terminal emulation software. TELNET is an application layer protocol which uses TCP port number 23. It is used to remote access of the device, but it is less used as it is less secure. The packets exchanged between the client and the server are in clear text. Okay, so next is NTP or Network Time Protocol. NTP is used to synchronize a computer's machine's time with another time source. We can use NTP or OpenNTP server, which provides client and server software for time synchronization. If we have lots of server and desktop machines in the environment, then we should have the NTP server so that all the servers can contact and update the NTP server provided by the ISP or the public time located at ntp.org. Then we have here DHCP, stands for Dynamic Host Configuration Protocol. DHCP port number for server is 67 and for the client is 68. It is a client-server protocol which uses UDP services. And also we have IMAP, stands for Internet Message Access Protocol. And it is an internet standard protocol used by email clients to retrieve email messages from an email server over a TCP IP connection. IMAP is a client-server protocol, and through this process, a user's email is received and held by their chosen internet email server. The default port of IMAP is 143 and secured is 993. And next, we have the LDAP, stands for the Lightweight Directory Access Protocol. LDAP is a directory service protocol that runs on a layer above the TCP IP stack. It provides a mechanism used to connect, to search, and modify internet directories. The LDAP directory service is based on a client-server model. The function of LDAP is to enable access to an existing directory, and it is also a protocol that makes it possible for applications to query users' information rapidly. Someone within your office wants to do two things: send an email to a recent hire and print a copy of that conversation on a new printer. Alright, next we have SSH or Secure Shell. SSH is a remote administration protocol that allows users to control and modify their remote servers over the internet. The service was created as a secure replacement for the unencrypted TELNET and uses cryptographic techniques to ensure that all communications to and from the remote servers happens in an encrypted manner. It provides a mechanism for authenticating a remote user, transferring inputs from the client to the host, and relaying the output back to the client. Next, we have also TLS and SSL. SSL stands for Secure Sockets Layer, and in short, it is the standard technology for keeping an internet connection secure and safeguarding any sensitive data that is being sent between two systems, preventing criminals from reading and modifying any information transferred, including potential personal details. The two systems can be a server and a client, for example, a shopping website and a browser. Or server to server. For example, an application with personal identifiable information or with payroll information. And for the Transport Layer Security or TLS, is a widely adopted security protocol designed to facilitate privacy and data security for communications over the internet. The primary use case of TLS is encrypting the communication between web applications and servers, such as web browsers loading a website. Then we have TCP, stands for Transmission Control Protocol. TCP is one of the main protocols of the Internet Protocol Suite. It is originated in the initial network implementation in which it complemented in the Internet Protocol. Therefore, the entire suite is commonly referred to as TCP/IP. Then for User Data Protocol or UDP is a transport layer protocol. UDP is a part of the Internet Protocol Suite referred to as UDP/IP. Unlike TCP, it is an unreliable and connectionless protocol. So there is no need to establish a connection prior to the data transfer. Though TCP is the dominant transport layer protocol used with most of the internet services, provides assured delivery, reliability, and much more, but all these services cause us additional overhead and latency. Next, we have IP or Internet Protocol. We have two versions of IP, which is IP version 4 or IPv4 and IP version 6 or IPv6. Most of the networks and systems in the internet is currently configured for IP version 4. Since IP version 4, the IP address has only 32 bits, and the IP addresses in the internet are running out quickly. Please note that there is a big block of these IP addresses are reserved for special purposes. For example, private network, and multicast addresses. And for IP version 6, since there is possibility that we might run out of IP address in the internet, IP version 6 was developed. IP version 6 IP address has 128 bits. This is a huge improvement from the 32-bit IP version 4. While a lot of networks are getting configured both IP version 4 and IP version 6, there is huge number of networks and systems in the internet that works only for IP version 4. But eventually, all these systems might go towards the IP version 6 route. Next is Internet Control Message Protocol, or ICMP. ICMP is the utility protocol of TCP/IP, responsible for providing information regarding the availability of devices, services, or routes on a TCP/IP network. Most network troubleshooting techniques and tools centers around common ICMP message types. We have also IGMP. IGMP stands for Internet Group Management Protocol. IGMP is used by the TCP/IP protocol suite to achieve dynamic multicasting. It allows a host to advertise its multicast group membership to neighboring switches and routers. Hosts identify group memberships by sending IGMP messages to their local multicast router. Under IGMP, routers listen to IGMP messages and periodically send out queries to discover which groups are active or inactive on a particular subnet. Next, we have the IPSec, stands for IP Security. IPSec is an Internet Engineering Task Force standard suite of protocols between two communication points across the IP network that provide the data authentication, integrity, and confidentiality. It also defines the encrypted, decrypted, and authenticated packets. The protocols needed for secure key exchange and key management are defined in it. IPSec can be used to encrypt application layer, to provide security for routers sending routing data across the public internet, to provide authentication without encryption, like to authenticate the data originates from a known sender, and also to protect network data by setting up circuits using IPsec tunneling in which all data is being sent between the two endpoints is encrypted. And then next, we have the Ethernet. Ethernet is the most popular physical layer LAN technology in use today. It defines the number of conductors that are required for a connection and the performance thresholds that can be expected, and provides the framework for data transmission. Okay, so the next is token ring. Token ring is the popular local area network technology developed by IBM that still has a large installed base in many shops but has been greatly outpaced in recent years by different forms of Ethernet. All stations connect to a central wiring hub called the Multi-Station Access Unit, and it is using twisted wire cable. Today, most token ring business networks have migrated to Ethernet. Token ring is more deterministic, which ensures that all users get regularly turns at transmitting. With Ethernet, all users compete to get onto the network. And for the last one is frame relay. Originally designed for transport across integrated services digital network infrastructure, it may be used today in the context of many other network interfaces, and it is also a cost-effective way to connect local area networks or transport data between endpoints in a wide area network. Frame relay is a standardized wide area network technology that specifies the physical and data link layers of digital telecommunication channels using a packet switching methodology. Ayan. So that's it for this video, and hoping na may natutunan kayo. At kung may mga katanungan kayo, contact nyo lang ako through email or chat. Okay? So see you on the next video.